Alright, in this video we're going to be taking a look at the area of a circle, and realistically speaking this shouldn't be that long of a video. We're going to do one example in essentially two different directions. The first, we're going to be given the area of a circle, or rather we're going to be finding the area of a circle, I apologize, with a radius of 7.8 feet. And for our second example down here, we're going to take a look at how to find the radius working backwards. So they gave us the area instead. And as you can imagine, any type of problem, it's helpful to be able to move forward and backward to do it. If you can work in one direction, it should make sense to be able to work in the other as well. Now, I've already mentioned in the last video the area of a circle. If you have forgotten it or you didn't see it in the volume and surface area videos, pi r squared. So you take your radius and square it and just multiply by pi. So for example, here it gives us a radius already. Well, there's no big mystery. This is actually just a very basic, straightforward, formulaic problem. The biggest thing to understand here is that you just have to be able to type things into a calculator, right? So we're going to put pi right here. We're going to drop a 7.8 in parentheses and square that. Now, the parentheses are not all that necessary here. If you're very careful about how you do things, all I would suggest is just make sure that you're using the actual pi key. I mentioned this in my last video about not rounding pi because it can throw things off. For me, for my own purposes, I like to be as accurate as possible. So any rounding that I'm going to do will be in the very last step of the problem. So here we're going to square our radius. Now I did not put parentheses on my calculator, but in this case it would not hurt. If you're not sure when to use parentheses, then maybe just go ahead and put them there instead, and then you'll never have to worry about it. Now they gave me a radius of 7.8. In fact, let me point out that was 7.8 feet. And here, this is going to round to a 0.1. I'm going to be consistent. If they rounded to one decimal place, I'll round to one decimal place. So I see about 191.1. And then I want to remind myself that area is a two-dimensional situation. So when I see r squared up here, for example, that's because we're working in two dimensions. If you're talking about a basic measurement like perimeter or circumference, that's when you have one dimension. That's when you can leave something the way it is. That's why the radius is just feet instead of feet squared. Or I should say square feet. In fact, I should point that out while I write this down. There is a difference between saying squared feet and feet squared. If I said 191.1 feet squared, that means I would square this again, which is not what we want to do. So it's not feet squared, even though it looks like that on paper. We read this as 191.1 square feet. Okay? Now, that's it for that. That only took that long because I like to ramble. So moving on to the second problem down here, we want to find the radius of a circle that has an area of 31.4, and that should say squared. It looks like I put down a 3 just out of confusion of myself. 31.4 square centimeters. Okay, so not centimeters squared, they're square centimeters. You always say the square first when you're talking about area. Well, we'll take a look again. We know our formula is area is pi r squared. And so what we want to do is input any information that we know. In this case, we know the 31.4, and that's a little different from our previous problem. In the previous problem, we were given the radius, so again, working backwards, already mentioned that. We see that this is a variable we're trying to solve for now, that's being squared and multiplied. We're going to start by peeling off the outer layer. That's this multiplication. You can think about there being an imaginary set of parentheses here. We need to divide pi off of both sides, which we will do here. And that's going to leave us with r to the second power. It's going to leave us with r squared. Now our parentheses that we're kind of thinking about are here. And of course the only thing left is that square. But we want to peel this thing off now. And hopefully you know then, I'm going to go and draw an arrow in this direction to save space, that r is just going to be the square root of 31.4 divided by pi. And so this is where we lean on our calculators because they're really helpful and save us a lot of time. We're working with decimals and things like pi. This is an absolutely wonderful time to be comfortable with a calculator. For simpler problems, I tend not to pull this thing out because why would I? But for a problem like this, I mean, look at that. That's not a number I would have come up with off the top of my head. And so we're seeing about 3.16. So we're going to radius approximately. In fact, I guess if I follow the same rounding method I did before, here this is also one decimal place. So 3.16 would actually be closer to 3.2 for the sake of this problem. And don't fall for the trap that many people will do here. We did an area problem here, so we put square feet. And this is an area problem, technically, but we're finding a radius. This is our R value. So for a radius, that is a distance. That is just a length. That is one-dimensional. That's just going to be centimeters. So there's no squared or cubed or anything like that. In fact, there shouldn't have been a cube here at all. I don't know why I did that. But here we are. That's the radius for this one. And that's really about it. For area problems, they don't get much more complicated for this type of thing. I suppose they could throw some algebra at you, but that would just be adding extra steps to an already pretty basic problem.